Here with me that are going to help me because we're going to have a quick discussion about multiple payloads and droids versus practicality. So I'd like to introduce the panelists now. We've got Yasser Bahjatt from, he's the founder and CEO of Aria Logistics. We have François Gervaix, who's a project manager from Centerfly. And we've also got Bart, who's from Payload. So we're going to have a chat about this now. So it's, do we fly drones or UAVs with multiple payloads? Interestingly, we all come from different backgrounds. I come from the hail sort of industry, so I'm looking at flying sort of reliable drones, sort of payloads for one long flights. Some of these guys come from the small, micro, and mini drone industry, and some guys come from the sort of infrastructure and logistics side of things. So it's an interesting question. Do we choose an aircraft to fly multiple payloads, or do we just fly multiple flights with separate payloads? So I'm going to ask you guys this question. Please use the microphones and carry on. So let's start with you, Bart. What's your thoughts on this?
Well, I think the question should be why are we asking the question? So it can be from 2 points of view, maybe. The first point of view will be if we select a drone, so it will be a question of which drone should we select from a technical point of view. So which drone is compatible with which payloads? Will it be able to carry out its mission carrying two types of payloads instead of one payload, or carrying multiple payloads? And the other point of view is, of course, the more economical point of view. So will we save money by taking a drone that does multiple purposes or multiple payloads, or carries multiple packages at once? But I think that's two questions.
Okay. But I think you also have to think about, is there a conflict with the drones, and are they going to interfere? So the payloads, are they going to interfere with each other? And have you got enough power capacity in the aircraft as well? Guys, please chime in. Please give me a few points.
Okay. So coming from drones that weight between 1 and 2 kilos, less than 2 kilos, say one payload is already a challenge. Having several payloads will be an extreme challenge. And however, the request from the market, from the user, was okay, I can afford one drone. I cannot afford to have several drones for several type of missions, and my missions are not always the same. So the minimum that we could do is make swappable payloads, easily swappable. It means that the same mission can be repeated in the next 30 minutes, in the next hour, with a different payload. And the new trend is probably to have flexible payloads or dual payloads. We try that for the last year, I would say, the last 18 months, and it seems that it's now possible. The technology is there to have two payloads or two types of cameras of payloads in one drone, and it seems to be something that is interesting and that is useful for the market.
So. For us in Aria, we look at this question from a total different point of view. We think at the end of the day, the consumer doesn't really care how many payloads you actually carry on a drone. What he cares about are the results and the data that he collects from those missions. So in Aria, we look at how can we build infrastructure with standardized payload swapping, with standardized battery swapping, with standardized package swapping, so that once you have a big enough infrastructure and a big enough network with different drones and different payloads on the system, the user just requests for a certain mission and a certain data collected, and then the network would automatically find the best assignment to achieve that mission, whether it finds a drone on the network that can support multi-payloads to do that quicker, or it goes and fetches several different drones from the network that each have a different specification and better quality with certain payloads. At the end of the day, the user himself does not need to buy all of this infrastructure because it's already on some sort of a shared network like the internet. He only pays for that small service that he gets for his specific mission.
Okay, but that's probably only very good in a large, well-established network, isn't it? Yeah, so carry on, please.
I think it addresses an interesting point. I mean, when we say user, for some people in this room, user is probably a drone operator. So he needs to know what hardware, what software is going to use. And for some people in this room, user is actually user of the output of the system. And in this case, I totally agree. It must be totally standardized, and I don't care if it was done with this brand or this brand, with two different payloads or two different flights. What I want is a standardized product. So maybe we have to be clear. Are we talking about the operator, the drone operator, or the end user in terms of product user, the data user?
In our approach, we kind of ignore the operator in the sense that we think if you have a large enough network, you can get all of these programmed to become autonomous, so the operator becomes a network, and the user is just the one who actually wants to benefit from the service. But yes, as you said, you have to get the network big enough to have all of these functionality, but before we can get it big enough, we need to kind of start working together within the industry to build those standards, and not just the standards on the UAV front, but there's a lot of standards on the robotics front on the ground to be able to automatically handle these different UAVs and payloads so that we can take out the human interaction. I mean, a lot of the time, I'm sure my colleagues here would agree, a lot of the time that's currently being spent on these missions is the human handling of these drones, the human handling of battery swapping, the human handling of payloads. But if I can standardize, therefore I can then automate, and then we can start bringing the network to a size that would service a lot of customers.
So we would have a system like we talked about this morning about Birdstop, their automatic system for battery swapping, and they could use it as a relay station, so you could change payloads. You could multitask the aircraft or the UAV quite quickly from a small sort of relay station, so you could have a range of payloads. That's what you're saying, a range of payloads and a range of batteries located around the country. Just
exactly, but right now there are some companies working on this, but each company has its own standards and its own way of doing things. What I think we need is a standardized thing across the entire industry, so that I don't need to build a new network with every new brand of UAV. So whenever a new company comes online and brings some new amazing features on a UAV that nobody else had, they can just add that into that network, and everybody on the network would benefit.
Okay, that's a good place to go. But then you have to start protecting data and making sure that only the person that's paying for that service can get hold of that data as well. So you have to make sure there's not a conflict in that. And are you also saying that we could do this across a sort of national area, or just are we talking very small geographical locations? Because some people will be working in quite remote locations, so it would be probably too expensive to put a big sort of network.
I think it's just, in fact, I think it will be cheaper because, as you said, it's relay points. So if you're going to very remote areas, you won't have to have a lot of high bandwidth relay points that would get you there. But if you're within a very busy area, you're going to have a lot of very high bandwidth. And when I mean bandwidth is relay points that can handle a large number of drones at the same time, that can handle a large number of batteries or packages. But if the moment you start going out of that zone, you might have some relay points that can only handle one aircraft and one battery swap at a time, but you can still deliver services a bit off the grid.
Okay. So another way of looking at this, you probably won't like this, but would it be better to fly slightly larger UAVs to fly multiple payloads, carry out some missions, or do you think that's increasing the risk level and the conflict?
Well, in my opinion, I think flying the risk that is associated with the drone, with the UAV, scales with the mass of the UAV. So, and the mass of the UAV also scales with how many payloads are you carrying. If you have to design a drone that carries 200 grams, and the drone maybe will weigh 2 kilograms, for example. If you say, okay, we also want this drone to carry another sensor, then you have a drone of 4 kilograms. It becomes heavier, it becomes more expensive. And I think the cost of a drone, or the savings that you have from a drone, is that it can maybe not now, because you always need a pilot for safety and for regulations. But the potential of drones is that they can do their tasks autonomously, so without a human. This means that it's not necessary to have one platform with multiple tasks. You can just have two platforms doing two tasks without having two people to control it. So if you can get the people, if you don't need one person per one drone, I think it might be more interesting to split up the capabilities of the drones and have one drone that's particularly good or at carrying this specific payload and another drone good at carrying another payload. Of course, if you have really expensive, so if it's a really expensive drone, for example, if it becomes expensive because you need to carry a radar system, communication, satellite communication, and the drone becomes really expensive, then again it's more in the advantage of only using one platform.
When you mentioned expensive drone, I took it quite personally because we produce drones that are from a relative point of view are quite expensive, and it's interesting because it was the main motivation to go to this swappable and dual payload system. Just because expanding, just multiplying the number of drones, just because of another payload was not possible. And I totally agree with the fact that the bigger, more payloads, more complex payload, more sophisticated payload requires a bigger drone. I totally agree with that, and we recognize that we went from 500 grams, half a kilo, we are now at 3 times that, just for one reason, a little bit because of endurance, but mainly because of the payloads are more complex, are bigger, are double in some cases, and we need more room, more payload lift times. Just because going from 100 gram to 200 to 300 gram needs a bigger drone, and then combining that with endurance, and of course, and about safety, I think it's slightly independent. I agree the mass is important, but if the software, if the autopilot is good, it will be good for 1 kilo drone or for 5 kilo drone. I mean, risk mitigation comes mainly from the quality of the software. The weight, of course, it's important, but I think if the autopilot, the software is good, then we can go with this.
I think what Bart said about once you can get the drones to be autonomous, then you really don't care as long that you can get it, because once it's automated, it can do it pretty quickly without a lot of human interference. So then flying 2 or 3 or 4 different missions to collect all the data you want is not really a big deal, and that's kind of why we were looking at standardizing a network, because then you don't really care about the human factor. At the same time, when you have some very expensive equipment, for example, a drone that needs to carry a LiDAR, which is already heavy and very expensive, instead of having to have your own asset that does that, the system would find a drone on the network or would schedule you. If within your area there's only like 2 or 3, once it's done with a mission, it would automatically reroute it to the next mission. And then with the risk mitigation is when you're going off grid. So if I'm going on missions that would go for 10 kilometers outside the city, for example, you might be willing to take more risk, because if it fails, if it falls, there's really low risk of harm to anybody, or you might even decide to change the total platform from quadcopters or vertical lift to something that has a winged drone. So again, instead of having to take those decisions individually, once you have all these capabilities within the system will be taking these decisions for you, and therefore make it much easier for you to just focus on what you actually want achieved, what data you want collected, or what product you want delivered, rather than trying to figure out all the technicalities of how that gets done.
I think we also can make a distinction between delivering things as a payload or having sensors to measure things as a payload. So from a package delivery point of view, I would think that it is more interesting not to gather a lot of packages in one drone, deliver it to one hub, and then have somebody delivering it to the people. So it's probably more interesting for logistics to just have one package for one drone, because then you can just fly directly from point to point in the network. And that's sometimes questions that people that are developing drones, they're doubting, should we make a drone, for example, flying between 2 points? Should we make a drone that can carry 3 or 4 packages, so we can load it with more packages? And then I think it's more interesting to make a drone just for one package, for package delivery.
But that starts to bring in sense and voids, because you're going to start to overpopulate the airways, aren't you? Whereas you've got missions that are specific for sensing and sort of data capture, and then you're suddenly going to start putting a sort of a separate network of drones out there to deliver parcels packages.
I think again within a network configuration, you would have different drones for different missions. So when we're talking about package delivery, if we just focus on package delivery, you might see drones that do a single package on the on the last leg, on the last mile, but then you'll have consolidation centers somewhere, and then when you drive packages between cities, you might decide to hand it over to a winged drone that can carry a collection that can aggregate a lot of these packages that are going between cities, rather than having 20 drones flying between the cities, having one drone that can carry this entire payload. So once you have a network like that, the system is going to automatically start deciding on how to assign these different missions and rerouting these packages or payloads. Sometimes you might, for example, have a mixture of these two. You might want to have a mission that uses a certain sensor that's very unique in a certain mission, but this sensor is on the other side of the country. Right? Rather than sending the very specialized drone that uses that sensor all the way, you might decide to have one of the delivery drones somehow bring it over to this bigger drone, and then on that station it will swap out. So once you have a standardized infrastructure system, there's a lot of possibilities that emerge because now you have a mixed capability. Rather than buying a single drone that has 1 or 2 capabilities, now you're subscribed to a network that has all the capabilities you want. It's just a matter of scheduling and you waiting for your turn to get these services.
Still working? Yeah, okay. So would it be interesting to have transport drones that are designed to carry always more than one package? So for example, if the maximum package is a box of this size, would it be interesting for companies to design drones that can carry 10 of these? Or should we just say, if this is the biggest package, then this will be the biggest drone, just carrying one package?
I think, first of all, in our company, I come from a computer networking background, so I'm thinking about the design just like I'm thinking about how the internet is designed. So we designed a package, we're calling it a chunk, just like a byte, and it's actually 1024 centimeters cube, which is just like the internet, the kilobytes. And then the idea is, yes, you can then design drones that can carry multiples of these packages. And again, this means that the drones that can carry multiples of these are going to be used for specific missions that require these multiple packages. So like long hauls between cities, for example, while the last leg delivery systems are always going to be focused on the single or double packaged system.
But then why not use 10 drones taking 10 packages instead of one big drone carrying the 10 packages in one drone?
So you have, for example, if you're going on a trip that's say 20 kilometers, right? You can use a drone that has wings and that can carry that bigger payload at a much lower energy consumption than using a quadcopter with one of these payloads. So having 20 payloads on a large winged drone, okay, might reduce your energy impact by 50 to 70%.
Why not using small winged drones that are also efficient and can carry then one payload?
Then that would be a discussion for the network itself, amongst itself. So if the network has a few drones that can carry a lot of payloads and has a few drones that can carry smaller payloads, it's going to do its own math to figure out, first of all, maybe not every station can handle the larger aircrafts in the first place. So it's going to do its own math. It's going to find its own paths and optimization to start assigning these missions. But as an end user, right? You don't care as an end user. All you want is your package to get from point A to point B. How the system design, like today when you're using the internet, you don't ask your provider that please only pass my data through this specific optical fiber. If it finds a way through a normal copper fiber that will still get your data, you don't care.
But from an infrastructure point of view, it would be interesting to have the maximum size of the drone, so that the biggest drone as small as possible, because then you don't need many sizes of infrastructure. For example, if
I mean, again, as a computer network engineer, nobody goes and says, look, you should set the maximum bandwidth of your switch to this technology, and so 10 gigabytes is the maximum, please don't try to do anything beyond that. That doesn't mean that everybody has to have a 10 gigabit switch, right? But at some high bandwidth backbone, sometimes you want the bigger bandwidth, you want the bigger speed, because the bigger drones, even winged, can achieve much faster speeds than the smaller winged drones. And that might be an optimal solution for high bandwidth paths between major cities. But then maybe between smaller cities or between urban areas, you might find that the quadcopter is more efficient, or you might find that a winged drone that has a single package would be more efficient. But then, so that's where we come, why we think we have to have a system, so that the system would look at that optimization. Of course, there should be standards for every size. So once there are standards, you can't just go ahead and decide, you know what, I'm going to double the drone size, unless you update the standards so that somebody would build a station that can handle that drone in the first place. Same thing with the internet. You can't just go and say, I'm going to do a 10 gigabit switch unless you update the IEEE standard so that everybody can communicate with that switch when it exists.
Okay, that's a really interesting discussion. It's obviously some quite polar viewpoints on that one. We're starting to run out of time now, so I'm afraid we're going to get into some questions. Unless somebody else has got any other viewpoints to make. But if there's any questions from the audience, that's all. Otherwise, we can continue the discussion. Yeah. Please. Okay.
More of an observation, but I love the way, the idea that you've packetized packages and that you treat it like a computer network, and that actually it shouldn't care what's going through it, and it just figures out the best way to do it with the resources it's got available. So yeah, I really like that. I don't have a question, just an observation that I thought that was very smart. Thank you.
The only thing we have on that is, unlike the internet, if we actually start building something like this for transporting material, unlike the internet, we cannot lose packages. Like, on the internet, you can lose a packet and it will just retransmit. In a system like this, you have to have an algorithm of routing that makes sure that no package actually gets lost, unless a drone falls out of the sky or something. Then it would have some kind of reporting mechanism to figure out what happened, how to redo the mission.
But then as the customer, I wouldn't care, like to your earlier point, that you would just resend it. The checksum didn't work, so I've resent it. So
unless the customer sent the package. So if I sent a signed copy of my book to a friend and that somehow gets lost in the way, there's no way to replicate that and recreate. So it depends on the package, and that's another thing that another layer that we're looking at is specifying the different packages, whether there are sensors being transported through the network, so if one gets lost they can find another, whether it's being a genetic product, whether it's being a high value item that needs, for example, an armored UAV to carry it. So then once the system like this exists, actually you can also start imagining it like the internet. So imagine the internet has file servers. Imagine with a network like this, I can have storage areas where I can plug in a package and just ask to store it in somewhere. Right, and then my friend kind of downloads it by just requesting it back from that storage area and automatically being shipped. Imagine, for example, farmers having silos that automatically package the produce into packages, and you can order directly from the farmer, and it automatically comes to you without any human intervention. So once a network like this exists, a lot of applications can be built upon it.
Okay. Okay, any more questions? Anybody else? Oh, yes, yes.
The two themes I've been hearing about today are the need for standardisation and pace of innovation. So, does the panel think that the pace of innovation is the friend or the enemy of standardisation?
Go on.
Yeah, so that's a difficult question, really.
Both.
Yeah. So I think it's good that there's a lot of innovation, and I think standardization is going to help the innovation. So, but it's going to be hard to decide which is the point in which we all agree on a standard for the drones, and that's going to be a hard point. So.
I think, in general, constraint helps innovation. So, the moment you have, a lot of times you find innovations are coming out because there are certain constraints put upon a problem, and suddenly you find innovative solutions for that. But when you have an open-ended problem, a lot of times you get lost within it rather than really being innovative about the solution. So I think standardization actually is a very interesting launching pad for innovation. But standardization in itself is an innovation, because as you said, we have to be innovative enough to get to a point where we can all agree that this is a standard that we need to follow, and this is something that we need as an industry to implement.
François, do you have a viewpoint? Because you've obviously had to innovate quite hard.
Yes, I think there is something in between innovation and standardization is the good practice, and it's something that usually comes with a bit of experience, and then we all or most user or most practical people will agree on some good practice, and then it will become a standard. Is it national or international standards? And I would say it's good for the innovation. I'm a little bit more concerned when it comes to these different layers of local, national, and international standards that are sometimes conflicting. But it's a different story. But yes, innovation, good practice, and then standardization. Totally agree.
I totally agree on the good practice. Yes. So, okay. Any more questions? We're all good. Gentlemen, I think it's. Any more questions?
Just one comment. Like, standardization does not always have to do with innovation or technology development. So I always look at the example of standardizing the shipping container. Nobody can say, well, this is right or this is wrong or this is the best practice of how to ship things. Somebody just decided this is the size of a container, and because of that, we have all of this innovation and standardization. We have a standard train that carries these containers. We have a standard truck that carries the containers. When I design a large ship, I know exactly how I'm going to design it to carry the maximum amount of shipment. If we never invented the shipping container, global commerce would not have been what it is. And there is nothing good or bad inherently about the design of the container. But what was good was once we agreed that that was the size, we were able to innovate on how to transport that shipping container from one side of the planet to the other.
Very good. Okay. Any more, gentlemen? Any more comments? Okay. Thank you very much.
Thank you.
Yes, thank you.